Hello again. So now this video is to show you how to solve the second problem of the extra practice worksheet. So this has that 2 moles of water reacts with 2 moles of sodium, producing 2 moles of sodium hydroxide and hydrogen. Right, this is a single replacement reaction, and let's see the questions here. The first question says, how many grams of sodium hydroxide are produced from the reaction of 5 moles of water with an excess of sodium? Second question says, what mass of sodium reacts with an excess of water and produces 3,500 grams of hydrogen? And number 3 says, 50 grams of sodium and 50 grams of water are placed to react. How many grams of sodium hydroxide are produced? Finally, we have number 4, according to the calculations, 18 grams of water produces 40 grams of sodium hydroxide. However, in the lab, with this reaction, a student obtained only 24 grams of sodium hydroxide. So what is the percent yield of this process? All right, so let's start with number 1. Number 1, you'll have to identify this is a mole mass stoichiometry, because you start with moles, you're being asked to calculate the grams, that's the mass. Right, so you start with 5 moles of water. So let's do that this side of the screen. Okay. So again, you have 5 moles of water, and you'll have to change those 5 moles of water to grams of sodium hydroxide. So you start with the mole ratio first. The mole ratio, according to the chemical equation, it's 2 to 2. Okay, so you have 2 moles of water with 2 moles of the sodium hydroxide, right? And then once you have the mole ratio, now you'll have to use the molar mass of the sodium hydroxide to calculate the mass. So it's like this: you have 40 grams of the sodium hydroxide with 1 mole of the sodium hydroxide. All right. So after calculating this and cancel moles of water and moles of water and moles of sodium hydroxide with moles of sodium hydroxide, you finally get 200 grams of the sodium hydroxide, right? So that's number 1. Let's see, this is number 1. Now, what is the number 2? The number 2 says, what mass of sodium reacts with an excess of water and produces 3,500 grams of hydrogen? So now for this number 2, you have to start with the 3,500 grams of hydrogen, and then you start with the molar mass of hydrogen, which is 2 grams of H2 are containing 1 mole of H2, right? And then the mole ratio. The mole ratio is from 1 to 2. So you have 2 moles of sodium per each mole of H2. Okay. And then now you are ready with moles of sodium. Okay, remember that you're canceling here hydrogen with hydrogen, grams of hydrogen with grams of hydrogen, moles of hydrogen with moles of hydrogen. Now you have moles of sodium, but you want to get to grams of sodium. Okay, so you use the molar mass of sodium, which rounded, it's 23 grams of sodium in 1 mole of sodium. Remember that molar masses will always have one mole, because they are the mass of 1 mole, right? So you cancel moles of sodium with moles of sodium, you finally get the grams of sodium. So let's calculate this. After calculating this, turns out to be 80,500 grams of sodium, right? Next question is the limiting reactant question. Well, the one involving chemical limiting reactant. So you have 50 grams of sodium, 50 grams of water, and you want to know how many grams of sodium hydroxide are produced. So let's do that. Okay, remember that we have this process in which we calculate the amount of moles produced of sodium from each of the two reactants. Then we compare them, we determine which is the limiting reactant, and we continue with the amount of sodium in moles that was produced, and we change that into grams of sodium. All right, so now that's going to be then the number 3. You have the 50 grams of the first reactant is sodium. You have the 50 grams of the other reactant that was water, right? So first you'll have to use the molar mass, right? Just like the one that we did before. You have molar mass of sodium. Remember that I'm using the rounded molar mass here, so it's going to be 23 grams of sodium in 1 mole of sodium. And then the mole ratio of sodium to sodium hydroxide is 2 to 2, is 1 to 1. So you can actually just, I don't want to say ignore it, but it's not going to change anything in the result, but the unit, right? All right, so this turns out to be 2.17 moles of sodium hydroxide and the other one, 50 grams of water. The molar mass of water, in 1 mole of water you have 18 grams of water, and the mole ratio it's also 2 to 2, that's 1 to 1. Moles of sodium hydroxide and moles of water, and this gives you 2.77 moles of sodium hydroxide. So this is the least amount of moles produced, right? So you continue with that, and you use that 2.17 moles of sodium hydroxide, and you change that using the molar mass, that is 40 grams of the sodium hydroxide per each mole of sodium hydroxide. And after canceling the units here, you get grams of sodium hydroxide, and this is 86.8 grams of the sodium hydroxide, right? Then, well, that's a lot for number 3, but that's number 3. That's the whole number 3 here, because you'll have to determine the limiting reactant and then calculate the grams of sodium hydroxide produced. All right, finally you have the 100% yield. This is the 100% yield. Okay, says according to the calculations, 18 grams of water can produce 40 grams of sodium hydroxide. So this is the theoretical yield. However, in the lab with this reaction, the student obtained only 24 grams. That's the actual yield. So you know now that the percent yield, it can be calculating by having the ratio of the actual yield over the theoretical yield times 100, right? So the percent yield then, it's equal, well, for this problem it's equal to 24 grams of sodium hydroxide over the 40 grams of the sodium hydroxide times 100. So this turns out to be 60%, right? So that is the percent yield. This is the problem, the question number 4 for this second problem. Remember that we already did, or you already did here, number 1, number 2, number 3. The number 1 again was the mole mass stoichiometry. Number 2 was the mass stoichiometry. Number 3 was a problem determining mass but involving the limiting reactant. And finally, number 4 is the percent yield problem, right? So that's all for these videos, and that's it. Okay.